Hello students, how are you? Hope you're fine. Now, today's class, let us discuss about formation of image in case of convex lens. What do you mean by formation of image in case of convex lens? We know, we actually studied formation of images or image in case of concave mirror, and we have considered different positions, correct? Here too, let us consider different positions of object and finally understand where exactly the image is found. Okay, let's start once again. Okay, I'm back. So our heading will be image formed by lens when objects are kept when object is kept, right? Is kept at different positions. What we are going to study? We are going to study nature of image form when object is placed at different places, at different positions. Fine. Once again. Before starting things, let us understand what are all rays to be considered while constructing an image. While constructing the image in case of lens, we know we need minimum two rays, maybe three. Anyway, we need two rays. Okay. What are the rays we need? What are the rays we need to what? To construct an image. Okay, let's start. Let us consider a thin lens. We know what is thin lens. A thin lens is one whose thickness is very small, negligible as compared to its radii. Okay. This is the first ray we have to consider. A ray which is parallel to principal axis. Let me consider this ray also. A ray which is parallel to principal axis. After refraction, will meet at F on this principal axis. F is principal focus. Here we observe what image of an object. Okay, this is a first ray. A first ray you have to consider a ray, of course, paraxial ray, which is parallel to principal axis, and after refraction it will meet at point F. First ray. What about second ray? Okay. Once again, let me repeat. Our lens is very thin. We have to consider only thin lens. Okay. In this case, as your lens is very thin, this O represents for optical center. A ray incident on optical center will pass without any deviation. A ray incident on optical center will progress, continue without any deviation. This is second ray we have to consider. This is possible in case of thin lens only. So we have to consider what? Thin lens. Okay. See, we are considering what? Concave lens as a standard here, correct? So we can draw what? Convex lens also. No need, this is enough if you understand. Okay. This is point 3. Ray 3. Whenever a ray of light is incident, a ray of light incident on refracting surface, say lens, and it is allowed to pass through principal focus. Then after diffraction, the ray will travel parallel to the principal axis. The ray will travel parallel to the principal axis. These three rays we have to consider. Using these three rays, we can construct image of an object. Okay? Ray 1 parallel to principal axis. This is exactly opposite case where ray passing through the principal axis and parallel to principal axis. Passing through the principal focus and parallel to principal axis. This is principal focus, this is principal axis. Okay? A second ray, which is exactly incident on optical center, will proceed without any deviation. Hope you understand. These rays let us consider. Let us consider these two rays only to construct images. We can consider all the three also, no problem with that. But let us consider only two rays. Okay. Now, I will draw a thin lens. Thin lens it is. A principal axis and optical center. Okay. Now, when object is placed at infinity, first position at infinity. First position is at infinity. Okay. A beam of light from this object will start. Of course, we have to consider this ray also. Will start and fall on this concave lens. After refraction, they meet at particular point. Here. This is nature of image form. Okay. This is where exactly the image is formed when object is placed at infinity. What is the nature? When image is formed here, we know it is inverted. It is inverted, point size, very small in size, and real. A real image is formed when object is placed at infinity, but size will be of point size. Size of the image is point size. Okay, good. Second, okay. See this. Now let me consider object somewhere. Object somewhere. Let this be 2f and this be f. This will be 2f. What is 2f here? See, in case of concave mirror, here we have F and here we have C. Where F is principal focus, C is center of curvature. And we have a relation connecting these two. This focal length, this distance, this is pole, this is small f, F is equal to R by 2. Where your focal length is exactly half of the radius of curvature. This is radius of curvature. Okay? Distance from P to C is called radius of curvature. This relation holds good for mirrors. Whereas this relation may not hold good exactly for your lenses. By your lens maker's formula, we know focal length depends on both on radii and refractive index of the material used. So, strictly we cannot use C here. What is better thing? Just 2 times of F will be 2F. Please remember, in case of lens, we do not use C. Why? To avoid confusion. Due to radii of two surfaces and refractive index of the material used, what we do? We use 2F, where 2F represent exactly 2 times of this, 2 times of this, 2 times of focal length. Okay? Please remember. When the object is placed, this is second position. When object is placed beyond 2F, let me repeat. When object is placed beyond 2F, let me repeat. When object is placed beyond 2F, then your image will form between F and 2F. Your image will form F and 2F. See the image. We can understand the nature. This is inverted, first thing we observe. So inverted image is real. We have studied so far. All inverted images are real. Hence this is real. What is the size? Size of your image is less than object size. Size of your image is less than object size. This is what we observe in this case. Okay. Now, let us consider object exactly at 2F. Let us consider object exactly at 2F. When you consider object at exactly at 2F, your image is formed exactly at 2F. When your object is at 2F, your image is exactly at 2F. What is the nature? Of course, two things we can say. One is inverted, second is real. What is third? Size of image is equal to size of image is equal to size of object. Hope you understand. Next, if object is placed between 2F and F, if object is placed between 2F and F, of course your image will shift beyond 2F. Formation of image shifted beyond 2F. And see that we observe it is inverted, hence real and enlarged than object size. Inverted, real, enlarged. When you place object between 2F and F, your image will form beyond 2F. When you place at F, this is opposite condition. As in case of infinity, this is a position 3, position 4, position 5. When object is placed at F, your image will form at infinity. You see that? Now we see. What we see? Okay. Your image will form at infinity. What is the nature of image? Remember, image is inverted, real, very much enlarged. When at infinity, image is at F. If object is at F, then image will be at infinity. Correct? What if, if object is placed between F and E? What if object is placed between F and E? We observe no real image form on the other side. We observe no real image form. See, virtual image, formed inside of the object. This is object, this is image. Virtual image is formed to the side of object only. Why virtual? It is erect, it is straight, erect, hence virtual and enlarged. Virtual, hence enlarged. Hope you understand. Here, object is placed between F and O. Hence, virtual image is formed, not on other side. To the same side, image is formed. This image is what? Erect, virtual. These are different positions. Where you can keep your object. And this was 6th one. And this gives information about nature of image form. This is important while solving problems. Okay? Or doing practicals. When you are carrying practicals there in your lab, you have to have some knowledge. What is object distance? If it is object distance, you have given focal length of your convex lens. Okay, you know focal length, so you can calculate 2f, and you can estimate if I keep object at this distance at f less than 2f, greater than 2f, where exactly will your image form. If you know this knowledge, it's very easy to measure their image distance and object distance. Hope you understood. You may not understand now, but while doing practical, definitely it is very much useful, and also solving problems. Now, question is, how to draw image formation using those two rays? How to form this? How to draw this? We will try one or two. Okay. Once again. Now, imagine you placed object in the first condition, right? Then we have to consider any two rays such that after refraction they meet at a point. This is easier. This is object. This is image. Here this is F. Here we have image. What is nature of image? We have discussed diminished, point size, real, inverted. Fine. Okay. Next figure. Let's see. Second figure. Say this is 12, and you are placing your object somewhere here. Correct. One second. Let me close of this. Okay. Then what we have to do? We have to consider two rays. Ray 1, after refraction, it will pass through F. What about second ray? Let us consider a second ray passing through what? Passing through your optical center. How? Without still so difficult, anyway I will try. See, this is a point of interaction. Intersection point. is point of intersection where your image is formed. If this is F, somewhere here we have 2F. When object is placed beyond 2F, okay, sorry, don't forget this, okay? You have every time you have to draw what ray direction. Without ray direction, ray diagram has no meaning. And I used to forget usually. Okay, don't forget this. And we will reduce by 1 mark. In main exam, if you forget to write a ray, then 1 mark is deducted. Then clearly, 1 mark na need and without any discussion. Please remember, it's very important. Oh, see, when object is placed beyond 2F, what we know? We know image formed between F and 2F. What is the nature of object? I mean image. Image is less than object. Inverted real. Okay. Case 3. Just practice at your home. It's quite interesting. Okay. This is 2F. Now we are placing object exactly at 2F. This is 4. First ray as usual. After refraction, will pass through F. Okay, they are not scaled actually. That's why some variation in the image will occur, but you must know the thing. Okay, a second ray. Okay, which is passing through O. Somewhere near the net C. This is 2. Once again, don't forget. Fine. This is object placed at 2F and you get image of 2F. What about the nature? Of same size. Both the object and image have same size and this is inverted real copy of this. Okay, next. Okay. When object is placed at F, somewhere here I am writing F. When object is placed at F, what about the see after refraction? Very easy. It was straight to F. This is O. This is second. Image is formed at infinity. Image is formed at infinity. Very big in size. Inverted, hence real. No problem with that. It's inverted and hence real. Okay. And last one. When you place, say somewhere near F, this is O, object somewhere here. What do you observe? First ray as usual, passing through the F. Second ray, passing through O. Okay. Now, this ray, correct? And this ray. If you trace it back somewhere near there, see, enlarged, erect image to the same side of object. This is object. This is image. Okay, image will never go to that side. Image will form on the same side. Okay, this is about convex lens. What about concave lens? We have to study that also. Okay, we can study that also. Once again, this is okay, concave lens, correct? Concave lens. I will place some object here. A ray of light incident like this. We know concave lens is usually called diverging lens. Hence, light diverged after refraction. Here somewhere we have O. Let me consider one more ray passing like this and retrace this ray back somewhere here. Sorry, I have lack of choppies. I forgot to bring those choppies. Okay. Here we have image formation of image. Okay, this is F, this is O. In all possible cases, wherever you place your object, virtual, diminished, erect image will form in case of concave lens. In case of concave lens, irrespective of position where you place your object, what we observe? We observe diminished, small, erect, and virtual, not real, virtual images form. This is the nature of image form due to concave lens. Hope you understood all of this. Okay. Now, next one. We have to study a concept called linear magnification. Linear magnification in case of lens. Okay. Okay. So let me write linear magnification in case of lens. What is linear magnification? Let me write linear magnification as M. Here too, in case of lens too, same definition. Linear magnification is defined as it's the ratio. It is a ratio of image height (HI) to height of object. Object height. It is a ratio of image height to object. Or simply we can write M is equal to HI by HO, also V by U. It equals to plus sign. Okay, no need to write. Anyway, please remember. What is V by U? Image distance by object distance. Image distance by object distance. See, by using this magnification, you can understand what if U is greater and U is less. Where U is greater and U is less, see here. If you place your object between 2F and F, what we observe? What we observe? We observe image is formed beyond 2F, correct? So let this be from this point This is V. What we observe? This is V, this is U. Correct? V is greater than U. Correct? V is greater than U. But negative. This is distance is negative, that distance is positive. So magnitude of M is greater than what? Here we can estimate that image formed is real as negative. Sign is negative because V is plus, U is minus. Finally, we get answer negative. Correct? We get answer as negative. As a negative, answer is negative. The image is inverted. Image is inverted. What is the size? It is enlarged. Magnitude of M is greater than 1. It is enlarged. It is enlarged. Okay. If M is positive, this M is positive. If M is positive, means V and U are positive, then image formed is virtual. Please, if M is positive, if this plus, just think why. Okay. In case of concave lens, if V is positive and U is positive, then automatically M will be positive. Then your image is virtual. If M is negative and your image will be what? Real. M is negative, your image will be real. Okay, please remember this, it's important. Next concept. Okay. Next concept is very important concept, of course, very important for 1 mark, 2 marks. ಏನೆಲ್ಲ ಕೇಳಬಹುದು? ಡೆಫಿನಿಷನ್ ಕೇಳಬಹುದು, ಇನ್ನೆಲ್ಲ ಕೇಳಬಹುದು, ಡೆಫಿನಿಷನ್ ಕೇಳಬಹುದು, ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೇಳಬಹುದು 1 ಮಾರ್ಕಿಗೆ, 2 ಮಾರ್ಕ್ಸ್ ಗೆ ಪ್ರಾಬ್ಲಮ್ ಕೇಳಬಹುದು. ಗೊತ್ತಾಗ್ತಿದೆಯಾ? ದ ಕಾನ್ಸೆಪ್ಟ್ ಈಸ್ ಪವರ್ ಆಫ್ ಲೆನ್ಸ್. Power of lens. Concept is power of lens. We usually represent it by P. We usually represent it by P. Power of lens. 1 mark ಕೇಳಬಹುದು, 2 marks ಕೇಳಬಹುದು, ಡೆಫಿನಿಷನ್ ಕೇಳಬಹುದು, relation between focal length and power of lens ಕೇಳಬಹುದು. Number of ways question may appear. Okay? Anyways. Okay. Let me draw. Take convex lens. Let us take convex lens as a standard. And a ray. This is a point where ray is incident. Okay, let me use this color now. This is optical center. Let the point say A. A is a point where this incident ray touches the surface. The distance between O and A, they represent it as h or height. Height, h stands for what? Height. Height or distance between O and A. Now we can define power of lens. Imagine, let me take one more chalk piece here. In the absence of this convex lens, this is a path taken by this straight line. This is a ray of light or beam of light, whatever. A beam of light could have taken the path along a straight line in the absence of what? In the absence of this lens. Due to presence of lens, we observe there is bending. There is bending. In case of convex lens, due to presence of lens, we observe bending in case of convex lens, and it may move away or diverge. Here it is converging. This ray is converging. It may diverge in case of convex lens. In case of concave lens, sorry. In case of concave lens. This is a convex lens, hence we observe convergence of the light. If it were concave lens, then what we observe? We observe what? Divergence of the light. Okay. The power of the lens is defined as tangent of the angle. This angle is delta. Tangent of the angle by which tan delta. Power of the lens is defined as tangent of the angle by which a lens converges or diverges. A lens converges or diverges. A ray of light or a beam of light, a beam of light incident on a lens at a unit height or at a unit distance from optical center. Let me repeat word by word. Please listen. Power of lens is defined as it is a tangent of the angle. It is a tangent of the angle by which a lens converges in case of converging lens or diverges in case of concave lens. A beam of light incident on it at a height or at a unit height or at a unit distance from optical center, or P is equal to tan delta. You can write tan theta also, no problem with that. If this is delta, this will be delta. Okay, from triangle, from triangle AOF, from triangle, let me write AOF here only. From triangle AOF, I can write tan delta is equal to tan delta opposite by LC. Opposite, this is delta, this is triangle, right angle triangle. AOF is right angle triangle. This is opposite by LC. What I can write AO by OF. Correct? This is tan delta by definition is power. It is a power is defined as what? It is a tangent of the angle by which. Correct? So I can replace this tangent by P. OA is nothing but height. At unit height, that is OA is equal to h, where h is height or distance from O to A. If h is equal to 1 unit, f is equal to 1 unit, then I can write OA as 1 unit. What is OA? OA is nothing but the distance is called, we know. So primary knowledge, we know this. OF is nothing but focal length. P is equal to 1 by f. Or you can define power of a lens is equal to what? Is equal to reciprocal of focal length. Power of length is equal to reciprocal of focal length of a given lens. What is the relation between focal length and Power of lens. What to answer? Focal length is inversely. Focal length varies inversely as power of lens. This is very important relation. It's very important relation. Please remember. Okay. Now. Now. Yeah, visible, right? P is equal to, okay, what is unit of focal length? We never discussed that, right? What is unit of focal length? See, focal length. Focal length. At the end, it is length. Focal length is nothing but it is a measurement of length only. Focal length. If focal, what is the SI unit of focal length then? Definitely, it's a meter. Focal length is meter. Now, P is equal to 1 by m or m raised to minus 1 or P is equal to diopter. Diopter is a unit of what? SI unit of power. SI unit of P is diopter. Diopter or simply D derived. Capital D represent what? Unit symbol for SI unit of your power. Diopter. Okay? Now, what is the SI unit of power? SI unit of power is diopter. What? Power of convex lens is taken to be positive. What we did? 1 second. Power of convex lens is taken as positive and power of diverging lens or concave lens is taken as negative. Remember, plus D stands for positive diopter for convex lens. Negative D stands for concave lens. Power positive for converging lens or convex lens and negative for diverging lens or concave lens. Okay, here the question ಏನೆಲ್ಲ ಬರ್ಬೋದು you may given. Okay, in 5 marks question ಅಲ್ಲಿ from question number 33, 34, 35, 36, 37 ಅಲ್ಲಿ if any question appeared from this chapter that's on this concept, you may have to find what? Focal length by some means and then power or power of number of lenses in combination. Please remember, in I ಹೇಳ್ತಿದ್ದೇನೆ ಅಂತಂದ್ರೆ ತುಂಬಾ ಲಾಂಗ್ ಕ್ವಶನ್ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡುವಾಗಲೂ ಒಂದೆರಡು ಮಾರ್ಕಿಗೆ ಆಸ್ ಎ ಪಾರ್ಟ್ ಆಫ್ ದಟ್ ಪ್ರಾಬ್ಲಮ್ ಇಟ್ ಮೇ ಅಪಿಯರ್. ಒಂದು ಸಣ್ಣ ಪಾರ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬಹುದಾದ ಪಾರ್ಟ್ ಆಗಿ ಇದು ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡದೆ ಬರಬಹುದು. Okay, so this is important. I hope I discussed all the things related to power lens. If you are very much familiar with power of lens, then okay, if time permits, let us discuss very few things about combination of two thin lenses. Combination of two thin lenses in contact. That's to in contact. Okay, very simple derivation. Usually asked for 5 marks. Okay, usually I ask for 5 marks. Okay, very simple derivation. Expression for visible. Expression for equivalent focal length, equivalent visible focal length of two thin lenses kept in contact. Kept in contact. Once again for 5 marks. Once again for 5 marks. Let me write very important one. Okay. The method in which we solve or we derive your lens maker's formula is very much helpful to understand this. The method, what we use is there, okay? Not exactly formula or anything or equation or anything. The method, what exactly I am telling. Let me consider two thin lenses. With principal focus. They are so thin that we can consider some common point of interaction. Okay? A ray of light is allowed to incident on first lens, say L1. L1 stands for first lens. L2 stands for second lens. Let F1 be focal length of first lens and F2 be focal length of second lens. Okay. After refraction, it's a first refraction. What are it will be? Refraction by first lens and refraction by second lens. Refraction by first lens and refraction by second lens. So ray will go and form real image I. Real image I on the principal axis. Similarly, I am going to say exactly this. As in case of lens maker's formula, let us imagine in the absence of L2, in the absence of L2, your ray will travel this distance and form, let me write here I1, okay, will form image here exactly here. Let me make it some straight line, correct? As much as possible. Straight line. Still not straight line. Leave it. Okay. Correct. Fine. And one more small mistake I did. Let me have this one. This is incident, correct? Just okay. This is object. Now this will be object distance. Please remember, I just forgot to mention object here, just the straight line. Okay. This will be what? Real image distance. Okay, sir. I will stop. And like this will be, this is V1. This is V1. V1 stands for this is the distance of image in the absence of second lens L2. Okay. So what we do here while deriving in the derivation, just first case. Okay. Before that, what we have to do? We have to consider here thin lens formula. What? Thin lens formula. Oh, this thin lens formula, we know. Thin lens formula is given by 1 by V minus 1 by U is equal to 1 by F. This is thin lens formula. You have to make use of this formula here. First point. Second point, in the absence of second lens, what is the nature of refraction through lens 1? We have to write it once. Refraction through lens L1. Then in second part, what we have to write? We have to write refraction through L2. Then get to equation simplified. We get expression for what? Focal length of two thin lenses kept in. Anyway, I will not derive now. This is the basic idea I have given. Tomorrow or day after tomorrow, let us derive the equation. Okay. Thank you. Thank you very much.